So now we have protostars. These protostars are spinning balls of gas. And when they spin, they generate a lot of heat. Very, very hot balls of gas. Now, since these are spinning around, these hydrogen atoms are going to start crashing. So after the spinning, there's crashing. This is nuclear fusion right here. Now we have a star. So when this is happening, we have stars. So a true star is a ball of gas in which nuclear fusion is happening. Different than a protostar. Protostar, there's no nuclear fusion. They're spinning, but they're not, they can crash in, but they're not fusing together. There's no nuclear fusion in protostars. So true stars, you actually have nuclear fusion. So protostars are different sizes. You can have extremely massive protostars, and you can have smaller protostars. Just like you can have large, massive stars, and you can have smaller stars. So our sun is really a medium-sized star. So we are going to just look at the sequence involved in our sun's life cycle. So our sun is what's called a main sequence star. That is the stage that our sun is in right now. And in this, it is hot enough for nuclear fusion to occur. So it's when that hydrogen core, so the hydrogen atoms in the core of the sun are performing nuclear fusion. They're forming helium. All right? And in this process, right here I'm demonstrating, they're forming helium. They also produce heat and light. And these are two forms of energy. So lots of energy. This is why the sun is bright and hot. So, this is the stage that our sun is in right now. It's a main sequence star. And it took, and it's been like that for about 5 billion years. But what's going to happen in another 5 billion years? All right, so let's look. So what happens is, when we have these hydrogen atoms crashing, what happens if we run out of hydrogen? There's no more hydrogen left, there's no crashing. So if there's no hydrogen left, there's no crashing, there is no nuclear fusion then of hydrogens. Helium, though, in the core now, can fuse to form heavier atoms, such as carbon, nitrogen, oxygen, all the way up to iron. So iron is the most stable element, and the very, very massive stars, they will actually be made of, the core will be made of iron. So if we just look at the sun, though, so our sun is a main sequence star. And what happens then, though, once it does run out of hydrogen, you have the helium core starts to shrink in on itself because of very, very strong gravitational force. So the gravitational force is greater than the pressure from nuclear fusion. In fact, there's no more nuclear fusion, so there's no outward pressure. So the inward pressure of gravity takes over in the core, and the core kind of shrinks in on itself. However, the outside, the gas around the outside of the main sequence star begins to expand and spread out. And that is when it is called a red giant. So this is what will happen to our sun at about, scientists estimate, about 5 billion years. So here we have a red giant. Once the red giant is formed, the outside of it is made of the hydrogen gas, and that hydrogen gas starts to spread out, expands in space. and becomes what's called Planetary Nebula. So remember, nebula is like a ball of dust and gas. But in this case, it's a planetary nebula because it does have a core. All right, and once it expands and cools, once that hydrogen spreads out even more, it starts cooling off. Because there's no more nuclear fusion. There's no more gas. So it cools off. And hydrogen spreads out. And you're left with that core. And the core then is called a white dwarf. So a white dwarf is the core of the planetary nebula because its exterior spread out in space. So it's left with the innards, the interior. And it's very, very dense. In fact, the volume is the amount of space an object occupies. So this has a lower volume than like a bowling ball. It has less space. But the sun, compared to this, is massive. Much more mass, much more volume. But white dwarfs are so dense that they take up the amount of space our Earth occupies, but yet they have the mass of the sun. So it's a lot of mass in a small space. Very, very, very dense. Right? And what happens is still cooling though, because there's no nuclear fusion happening. So it's still cooling off. And then it becomes what's called a black dwarf, because there's no light being made, there's no heat left. When all the heat and light's gone, it's called a black dwarf. No more heat, no more light. And then they can become an actual pulsar. So a pulsar is a spinning neutron star. So it's made of neutrons, which are part of atoms, and it spins and produces radiation. So it's a pulsar, and that is really the corpse of the star. All right, so this pathway is for stars that are about the size of our sun.